Hello, everyone. Good evening, and thank you for joining. Welcome to tonight's webinar, and I trust there's going to be a pleasant one for each and every one of us. We already have a speaker on the seat and waiting to dish out what he has for us. We're going to start in a few minutes. We have about wait for an extra 4 or 5 minutes to have more other persons joining, and then we'll start off with introductions, and then I'll read our speaker's profile for tonight. Once again, thank you for joining and stay expectant. Thank you, everyone. All right, everyone. Good evening once again. My name is Michael Madru, the AI and machine learning instructor here at Mindflux Academy, and I want to especially welcome you to tonight's webinar. With me here is someone that I respect and regard at the highest esteem. He's someone that has personally influenced my life and someone that I look up to greatly. All right. I'm going to quickly read his profile and then so we can get an insight into who he is, and then it will help us. So having him here tonight is something that I do not take lightly. So I know you have to leave a lot of schedules, a lot of things to even attend to us. So this is me saying thank you especially to him. So we've been here this evening as our speaker is Mr. Samuel Ayo. He's a senior AI engineer, a data scientist, and he's the head of engineering. Samayo is a seasoned and highly skilled hands-on AI engineer slash data scientist with years of experience in software, data, and AI consulting. He has a proven track record in the design, development, and deployment of machine learning systems enterprise scale data products, and multi-phase AI solutions. With a background in economics and AI, Samayo is a three-time AI hackathon winner and has been heavily involved in building machine learning solutions across various cross-industry fields, including media advertising, IoT, Internet of Things, energy. Sam Ayo's expertise and achievements have earned him speaking opportunities at prestigious events. He was invited to speak at the Nigeria Computer Society, the global body for science for computer science in Nigeria, where he shared insights on the intersection of AI and business impact. He also had the privilege of speaking at the Microsoft Student Learn community, delivering a talk on leveraging AI for real world applications to aspiring technologists. In addition to this engagement, Samaya has also been a featured speaker in the Ehin Betty Summit for Technology, a renowned conference that brings together thought leaders and industry experts to discuss technological advancement and their impact on sectors. At this summit, Sam Ayo provided valuable insight into the transformative power of AI and data science in driving innovation and sustainable development. As a versatile and dynamic professional, Samayo is now a results-driven leadership, which he thrives on problem solving, creating value streams across product delivery life cycles, and delivering outstanding results that help companies take their from plan to prototype and then to profitability. Beyond his professional accomplishments, Samayo is dedicated to knowledge sharing and collective growth. He actively engages in community mentorship, open source development, meetups, meetups facilitation, technical writing, and research, contributing in no small way to the advancement of AI and data science. With his deep expertise, excellence, and passion for knowledge, Sam Ayo is a sought after speaker and a valuable asset in driving innovation and success in the field of AI and data science. So it is with this honor that I would like to specially welcome Dr. Sam Ayo to our midst this evening. Over to you, sir. Thank you for joining us again.
Yeah, thank you so much. Really humbled to actually be here. Can you guys confirm if you can actually hear me?
Yes, sir,
And
I
if you
can.
can also hear me loud and clear. All right, awesome. Awesome. 1 minute, let me show that my sound is all good. For me, it's always really very exciting when I find people with very high high esteem or high drive for value, right? Especially in an ever evolving field where we still have pretty much low participation in Africa. I know it feels like, oh, we have a very high participation in Africa when it comes to artificial intelligence and machine learning. But I can tell you for free, we still have pretty low participation for many reasons. Many of them being that we still have a very large gap, right? We still have a very large gap, and this gap is in terms of skill. We have a lot of enthusiasts in the field, but we don't have a lot of people who are already seniors and are actually doing so much for the community to grow. So for me, it's always a thing of it's always a pleasure if I get to be in that position where I can democratize knowledge. I'm a big fan of knowledge democratization. I mean, it's for me, it's a big for to democratize knowledge. Yeah, so and discussing tonight is actually on a very important and exciting topic that really touches on agentic AI and where we are with it, especially in terms of use case um, and value, right? Emphasis on value is because of our ecosystem, especially in Africa. Value is something that is the engine that changes or drives innovation, especially disruptive innovation. I'll give you a case in note, right? You find that there's very slow adoption of autonomous technology, whether AI or non-AI. By the way, it doesn't have to be AI to be autonomous, right? It has to be AI or data-driven to mimic intelligence, but it doesn't have to be AI to be autonomous, which means we can have autonomous systems that are not AI driven. Very important distinction to be able to draw a contrast on. All right, so that's why we have industries that have that are reached to growth in terms of technology adoption, because we still have that struggle or that tight grip on innovation that has value for disruption. I mean, that's a whole big thing to actually talk about. So tonight we'll look at what exactly are AI agents, right, and how do they serve distinctively from autonomous systems and chatbots. And then we're going to use that to drive our discussion, and then touch down on all this is exciting. All right. So I don't think I need to go too deep about myself. My name is Sam Ayo. Uh, my journey actually began from software engineering, and then I scaled up into data science, and then specialized in artificial intelligence and machine learning. I'm an artificial intelligence Board of America certified AI engineer. Uh, I'm a contributor to Pinecone. Pinecone is the vector DB giant in the artificial intelligence space. I'm a contributor, and I'm a Microsoft certified AI engineer, and I'm a father and a loving husband. All right, so when we talk about agentic system, what are we really talking about, right? Again, there's always this big disparity about what really do we consider agents. There's agent in the mathematical terminology, there is agent in the physicist terminology, there is agent in the psychological terminology. But if we were to reconcile all that together and talk about what really is artificial intelligence, agentic system rather, in the scope of artificial intelligence, would largely be referring to an agentic system as a system that exhibits planning, decision making, and environmental interaction in an intelligent-like manner. Now, I always like to talk about this when I get to talk about intelligence, especially when it comes to computing and sciences, because there is no direct definition for intelligence when it comes to sciences. Yeah, I'll say that again. There is no direct definition of intelligence when it comes to sciences. As a matter of fact, when it comes to biology, there is no direct comparison of intelligence, because everything is intelligent in its own ecosystem. A dolphin in its ecosystem is intelligent. A human in our own ecosystem, we consider ourselves intelligent. An ape, monkey in their own ecosystem consider themselves to be intelligent. They are limited by the scope of their ecosystem. That does not mean that they are dumb. All right, they are smart in their own ecosystem, because if you are to bring a human into the habitat of a fish or a whale or a dolphin, they would perform better than us. Case in note number one, we cannot breathe underwater, but they can, right? They're adaptive to do that, right? We cannot maneuver underwater. They can do that, and they are adaptive to do that. For us to be able to do that, we need to come and create specialized skill that takes us out of our habitat and ecosystem into their own habitat and ecosystem. Now, some would argue and say that, oh, we are intelligent, and that is why we're able to create those tools. Well, those animals, right, in their ecosystem are intelligent. That's why they are able to adaptively create that without any form of external or exoskeletal engineering, right? I want to believe I'm talking to a very technical audience, so my choice of words, I'm not going to try to water them down, right? But I'm sure everyone's following, right? If you can just give me an emoji reaction, so I'm sure that I've not lost it. My exactly. All right, cool. That I've not lost with the crowd. Okay, so intelligence in itself, right? It's a very contrasting and disputive topic to actually talk about. But when we bring that into our own ecosystem in terms of software engineering and sciences, we do not consider artificial intelligence to be any intelligent system. We do not do that. Why? Because the entire goal of artificial intelligence is to design intelligent-like systems. That is, systems that mimic intelligence. Now, case in note, we can design a robot dolphin. It mimics the intelligence of a dolphin. We cannot consider it to be intelligent in the scope of a human because it cannot perform human function. Even as where the scale of intelligence that we experience right now at scale, right? In this case, ChatGPT, that's from OpenAI, Claude from Anthropic, Gemini from Google, they are they in themselves are not even actually intelligent, right? They are just mimicking intelligence based on probability. So what you're actually experiencing that feels like a smart AI is actually an AI that has been trained on a large amount of data sets to be able to connect words together and predict the next word that should follow. Right. So if we were to give my slide now to an AI, right, it will not be able to make sense of it if it had never encountered any of the words there. That is why AI performs poorly in very remote natural languages in Africa. For example, if you give it very sparse languages, tribal languages in dense areas in Africa, maybe in remote forest or very deep rural areas, it cannot understand what they are saying because it has never seen that data before. So it is intelligence to the degree at which it can mimic data it has already been exposed to. So we do not consider artificial intelligence to be intelligent. We consider it to mimic intelligence. All right. So if you bring that artificial intelligence into a system where it can exhibit planning, it can make decisions, and can interact in an environment, we consider that system where the artificial intelligence is residual to be agentic. All right. Now, when we talk about agentic systems, we actually talk about agentic system within the scope of two things: tool calling and tool recognition. Now, good enough, we now have more advanced reasoning models that are produced by model giants. GPT-5 is out now. I know there's a lot of thrashing going on GPT-5, and that's totally understandable, right? GPT-4 still remains the benchmark in terms of performance. We have Claude 3.5 Sonnet, we have Gemini 2.5 Pro and Gemini 2.0 that can be put in an agentic case and be able to perform agentic actions. Now, when we talk about this in terms of agentic scope, we actually talk about two things: tool calling and tool recognition. Now, tool calling is the ability for an agentic system to be able to call tool, right, or for an LLM to be empowered with the capability to perform or interact with the environment via tool calling. Now, tool recognition is the capability for any LLM in an agentic system to be able to identify appropriately the right tool to call in a myriad of tools, right? So these are two very distinct things. We find a lot of research and understanding going into tool calling, but very little understanding going into tool recognition. Because again, tool recognition is directly proportional to the propensity of the model to be able to reason at scale in data with very wide variance. All right. So you can find out that if you take a less empowered model that's lower of reasoning, take for example Gemma 3, right? That's not as powerful as big giants like Gemini 2.0 Pro, and you give two of them a wide variety of tools to work with and perform multiple actions agentically. Gemma is going to fall flat on its face, right? Because it does not have that much capability in terms of reasoning that Gemini 2.0 Pro have, that to be able to recognize tools appropriately and be able to use them. So again, it takes us down to two aspects when it comes to agentic building and agentic AI, which is tool calling and then tool recognition. So let's distill or let's unpack the context within agentic systems by examining the components of agentic AI. Now, when we look at agentic AI, we can build it on on a tripod standard. That is, technically it has three legs, like planning, decision making, and environmental interaction. So when we talk about planning, right, we're actually talking about, so please do not mind Michael Madu showing on my slide. I mean, he's a great guy, and he's he provided me with this slide for the whole branding, and his school that names there. All right. So when we talk about components, right, on of agentic system, we'll start with planning. Now we can break planning into two parts: context awareness and thought creation. Now, why do you actually need to know this? It's because for you to be in this webinar, it means that to a degree, you are either a C-suite individual who is leading AI engineers and ML engineers, or you yourself, you're technical enough and you are an AI engineer or an ML engineer. All right. So, which means that theoretically, you need to already know what these things are to be able to make tough decisions around system architecture and system design. Now, when it comes to planning, it's broken into two parts, right? Context awareness and thought creation, which means that it leverages on the capability for the LLM to be able to make plans, right? And be able to think creatively around what it needs to do. For example, if you have an AI system, all right, and that AI system is meant to, give me a minute, I need to be sure that I'm working with the time. All right, cool. All right, I'm still well within my limits. So if you have an AI within an agentic system, and you need it to perform these three actions sequentially, you're taking a trip to Dubai, and so let me use something more concrete. You're taking a trip to Sweden, right, from Nigeria, and going to Sweden, you need to book an airline, take a ticket from an airline. You need to get sweat or cardigan or something to prepare you for the cold. And then you also need to book an hotel. So these are the three things you need to do. So you come to an agentic system and you say, I need to prepare for my trip to Sweden. Now, a very high reasoning LM within an agentic system needs to first be context aware. What does the user plan to do? Right. The user is planning to take a trip to Sweden. Where is Sweden? What is Sweden about? Now, again, it now needs to also be context aware. What tools do I have to prepare or to plan for the action that this user needs to do? Then it comes back to thought creation. Right. The user is going to Sweden, which means they need to prepare, which means they need to book an airline, which means they need to book an hotel, which means they also need to prepare for the cold because Sweden can get cold at certain times of the year. All right. So it takes an LLM with good reasoning capabilities to be able to first move through this component in an agentic system by creating context around queries or around requests from users, and also be able to frame its thought, to be able to plan and decide to the next part of what it's meant to do. And that leads us to the next part of a component in agentic system, which is decision making. All right. So decision making is a critical part in every agentic system because it breaks down again into two main components: reasoning and the ability to articulate steps to solving complex problems. So let's go back to our example of a user going to Sweden, right? Now, the agent has put thought around it and put context around it as well. Now it's time for it to reason, right? Reason in this case is it needs to look back on what it has in the historical conversation with the user, and then leverage its capability, right? Its predictive capability to be able to reason strongly in terms of solving problems, and then come back again, right, to articulating its steps on how to solve this problem. So the user is going to Sweden. What's the first thing that needs to happen? Right? If I don't need to quickly go and book the ticket, I need to check, does the user have finance for this? If I do not have access to check either their Chase bank account or to connect with any banking system that they have, right, then I need to ask the user if they have the resource to be able to take on this trip. So this is actually very critical, right? Because it allows agentic AI systems to be able to take on broad tasks, that is a wide variety of tasks, where taking decision is actually very important and the decisions can go in many directions. So for such kind of system, reasoning and articulation of step is really, really important. Now, why is this actually super important? Is because this influences, understanding this in the component of an agentic system influences your technological choices, right? It influences your technological choices. It influences your programming language of choice you want to use to build the system. It influences your model of choice you want to use to build the system. It influences your system design choices as well. How many tools should they have? What tools should be prioritized over other tools? What tools should it strongly rely on as a fallback to curb hallucination? What tool should it use to make this project successful at an MVP stage before moving to prototype? All right. So understanding this opens your mind to other aspects that governs or controls the project in itself as you build or as it scales as it goes. Now, being able for such a system to be able to take reason efficiently and then distill the problem into different micro simple tasks that can be solved, it then now looks forward to what can I use to solve this problem. And that takes us to the next step, which is environmental interaction. All right. That now takes us back again to what we just opened the discussion with, which is tool use and tool recognition. All right. Now, recall I spoke at length about tool calling, which is tool use interchangeably, and tool recognition, because if we were to continue with our example that we spoke about, we get to realize that after after planning, after coming into a decision on what to do, it needs to be able to, the system needs to be smart enough to be able to recognize the tool to use. Let me give an example. Let's assume that this same system that can book flight for you, that can book an hotel for you, and that can also check your account balance as well, right? And also check the weather for you, can also check your email for you. I mean, let's assume it's a fully fledged, multi-capable agentic system. Now, it needs to know that it's not supposed to email any organization or any agency to book your ticket yet until it confirms using Google search that they exist. Excuse me. Again, right, it needs to also know that if it sends an email to that agency to make inquiry about booking your flight on your behalf, it needs to check your inbox. Call the tool that checks your inbox to be able to also know where to check if feedback has come back. So tool recognition plays a very strong role in environmental interaction for agentic system. All right, it plays a very strong role because it gives it the capability to be able to properly identify what to, how to do it, when to do it, and what to prioritize as it does it. Again, when it comes to environmental interaction for agentic system, this is where there usually is a lot of work, right? Because it takes high effort to design, and I'll explain why it takes high effort to design this, right? And it also depends on a resilient multi-architectural AI system, right? And it also enables non-LLM capabilities. In this case, basic LLM do not come pre-built with the capability to search the internet, right? Or to be able to know beyond a certain date where their training data elapsed. So giving the capability to interact with with its environment gives it the capability to be able to do much more beyond what is already present in training data. So let's expand a bit more on environmental interaction in terms of tool calling body of work. Um, I always like to break tool calling into three phases, right? And then further break it down into more phases. Now, when it comes to tool calling and expanding what it actually is, you find out that you can break it into three parts, right? Then you can take that three parts and break it more into three more parts. But let's start with basic three parts, right? Which is the input into the tool logic, and the tool results, right? So for every single tool that any agentic system uses to interact with the environment, it always begins with an input. So what does that mean? I wish I had like enough time to really crack down on this. I would have loved to show some coding examples, but I mean, we can make do with that at a much later time. But every tool that any agentic system uses takes in an input. Let me give an example again. If we're working with a weather tool, it takes in the location. The location could either be longitude and latitude, where the tool now does the tool logic. The tool logic in this case means that it needs to call a tool a weather service. Could be Open Weather, could be Google Weather. It just needs to call. That's where the tool logic comes in. Again, an input, right, needs to come into the tool. Using our weather tool as an example, it could be the longitude and latitude of your location you're actually going to. Right, then the tool logic would be to call external API services, and then the tool result comes back. Now, depending on how the tool result is structured back, would it bring back the weather in 7 days? Would it bring back the weather in 30 days? Would it bring back the weather in 5 days? Would it bring back the weather today, but in a time range, right? It becomes a time series decision. You need to make the tool calling. So again, if the tool in this case for environmental interaction was to book an hotel, it would need to use Google search, right, as a tool, which means the input needs to be hotels in Sweden close to the airport, right? So which means that, or hotel in Sweden close to if you're going for a conference, hotel in Sweden close to conference location, all right? So then Google search in the tool logic will return the result, and then that result will then be streamlined, cleaned, and then returned back to you for the AI to be able to understand and make more sense out of it. In case you note, you need to distill out or shred out any information that actually makes no sense or would bloat the capability of the system. Now let's talk a bit or focus more on input and body of tool body of work that focuses on the input to every tool. Now, when it comes to building or constructing a tool for environmental interaction for any large language model, it is usually important to focus on three things: tool description, right? Tool input. Let's start with tool input first, tool description, and then tool result, right? Now, these three are actually put in as description. They are description in the tool, right? Tool input. So what is the tool expected to receive? Because the LM is going to read that information from the tool description and use that to respond to the tool. So what is the tool input? Is it going to be string? Is it going to be float? Is it going to be integer? Right? What is the tool description? Now the tool description carries a lot of weight, right? In the tool body of work, because the tool description gives the LLM a very clear idea of what the tool uses and aids it for tool calling and tool recognition. So it has to be clear, very unambiguous, and very precise on what that tool is meant to do. All right, then the tool result will also help the LLM anticipate what is coming back. Is it a JSON, right? Is it a list or an array? All right, so it needs to prepare for what kind of result is coming back. All right, so you really cannot talk about agentic systems without making mention of RAG systems. But in this session, I wouldn't spend so much time cracking down on RAG, right? Instead, I would focus more of the time talking about very critical components in RAG systems. And that involves trunking strategy and the embedding strategy, all right? Because these two are actually very important when it comes to empowering RAG systems or empowering large language models with RAG. Now, when it comes to empowering agent AI systems with RAG, it's all about strategy, practically. It's all about strategy. So let's focus on the very first step in any agentic system that's empowered with RAG. and that would be chunking strategy. Now, your chunking strategy actually depends on what your data looks like and what you need from your data. If you're working with, what would be a better example to use now? Transcription services, right? If let's say you work in a transcription service where you train your business or what your company does to transcribe audio, video, and then give it back to the user, you would realize that your chunking strategy would be very different for someone who works in financial domain, right? Why? Because if you work in a transcription service and you're transcribing data and then putting in the rack system, your chunk size will need to be large, right? It needs to be large, and then your overlap would need to be minimal. Now, what does that mean in your chunk sizing to be large? Because if the system is going to embed that and put that in and need to perform similarity search, whether it is going to do that similarity search over some advanced technique like maybe graphs, right? It would need to ensure that it provides relevant information that contains complete context of what is being spoken from the original source data that was transcribed into text. All right. So again, what you must consider when you're designing your chunking strategy for any business that you're building a agentic system for is your chunk size. You must consider it, and that is directly related to what the business is offering. All right. Your chunk size, your chunk overlap, and your chunk splitters. Now, chunk overlap refers to how much of the end of a first chunk is present at the start of a new chunk. So if you chunk a document into 20 places, we're saying that the first chunk and the second chunk, the end of the first chunk must be present at the start of the second chunk. That way, the information can be cross-referenced and they can also be connected, right? Then splitters. Now, when it comes to chunk splitters, there's a variety of technique for chunk splitting. There's semantic chunk splitting, there's intelligence chunk splitting, there is context chunk splitting, there is punctuational chunk splitting, there's HTML chunk splitting, there's markdown chunk splitting. There's a lot of kind of chunk splitters, right? But again, the decision of what type of splitting to use depends on you and the problem you're trying to solve. Now, for example, if we're going to go back and talk about our transcription company, right? Your splitter you're going to use would likely have just only two options for you to look at. One, sentence splitters, that is splitters that look for end of sentences like periods, right? Or what we call full stop, right? So they look for that. The splitter will look for that and mark that as the end of a sentence and then split from there. Or you could introduce intelligent splitting where you look at the full end of a statement that bears context, right? And then use that to split. Okay. So let's talk about the embedded strategy, right? Because again, once you know about the chunking strategy, it's much more easy for you to then talk about the embedded strategy. And the embedded strategy is actually a bit more steep than the chunking strategy because the embedded strategy or highly impacts how your system performs at a very grand scale, right? Because your embedding model you're going to use has been trained already. So your embedded strategy is practically just an LLM that is a kid. Let me put it that way, right? You can see a baby LLM, right? But it's not trained to be conversational, but it's trained to be semantically intelligent like. All right. So what that simply means is that it's been trained on certain corpus of data to understand relationships between target context or target words that have been converted to tokens, and then be able to create accurately the similarities, and then use that to group them together. So your embedded strategy depends on your accuracy, cost, and use case needs. So how accurate do you expect your RAG to be, right? Or how efficient in terms of cost and spend do you expect it to be? Because there are some closed source embedding models that are actually very, very good, but they're expensive. And there are some open source ones that are also very, very good, right? But they all have They all have sloppy moments that they die down, and then they also have moments that they exceed expectations as well. So what must you actually consider? Accuracy. Now, how do I know the how what embedding model to choose, and um, what do I look out for when I'm picking this model? Now, a good place you can start with the MTEB Leaders Board on Hugging Face, right? It gives you Hugging Face MTEB Leaders Board has a list of models and how those models are performing across different metrics, and then you can use that to make your decision. The appropriateness for the task. So any model you're choosing, you need to go and check how that model was trained, what it was trained on, and what specific tasks the model creators said it excelled at. Speed of computation, right? How fast is the model? How large is the model? And then length of output vector. So models have different length of their output vectors that you need to consider, because the length of the output vector is directly related to the vector DB dimension. All right, so every vector DB has a dimension for which it's going to create allocations for your embedding token, for your tokens when they have been converted by the embedding models. So you need to prepare for that. Then the size of the input. Again, every embedding model has a size of input. Remember I said that they are just very small LLMs. LLMs have size of input that we call context window. That is the ability for them to be able to assimilate information at one call, right? Just like human beings, we have context window as well. But we know ours is very large and it's at a varying scale. So these models also are designed to mimic intelligence. So they also have size of input, which is the context window, that determine how much information can you stuff into the model at once that it will be able to assimilate it, that it will not, it will fall on its toes, right? So it's pretty important that you incorporate all this to be able to understand how to be able to use and design rack systems efficiently. Now, for your embedding strategy, you need to understand that what embedding models do is they take in text, they convert them to mathematical representations, which is vectors that are also called tokens, and then return that tokens for you in a dimension, right? The dimension that it returns is directly related to the length of the output vector, and they are usually like NumPy arrays, right? Not all models follow NumPy array format, but you can always convert them to NumPy arrays to be able to understand how they stack, right, as vectors. Okay, so what does an agentic stack actually look like? Agentic stack could be an agentic system that leverages any and some of all these, right? We have Fast API that allows you to serve your application. You have LangGraph that allows you to design agentic orchestration. You have PyTorch that is leveraged under the hood by Hugging Face to be able to load open source models, embedding models as well. We have weight and biases that allow you to evaluate the performance of your agentic system as data moves through it, and eval your RAG as well. Then we have Python Lightning that is one of the boys in the club that provides ways for you to also serve agentic systems or systems that leverage LLMs at very, very quick and lightning speed deployment style. Now, agentic systems, as I mentioned from the onset, are intelligent-like, which means they seemingly exhibit autonomous behaviors and how to work. For chatbots as they are, right, we can safely say an agentic system can be a chatbot, but a chatbot cannot become an agentic system. Let me say that again. An agentic system can become a chatbot, but a chatbot cannot become an agentic system because everything comes from the design. If a system is designed to be just a chatbot, then it has no environmental interaction. You can only just chat with it. At the onset of ChatGPT around 2021, 2022, right? Or let me not say ChatGPT, let me just call it GPT because that's what it was then. At the onset of GPT, it was just a chatbot, right? It made a lot of noise because as at that time, Saka, the emergence, right, chatbots were usually just static corpus of data, right? They were static corpus of data. They really didn't have any degree of smartness to themselves, which means that they are confined with the scope of the creator, right? And they do not exhibit strong intelligence across wide domain. Their domain actually just they are limited within their domain, right? But then when we had large language models, we saw that explosion, right? A doctor can chat with it, a lawyer can chat with it, a scientist can chat with it, right? It had cross-domain experience and could do a lot of stuff, right? Which made it super cool. But that does not make it an agentic system because it cannot interact with the environment. Right? But an agentic system, you can charge an agentic system because under the hood, it is part of its component is that LLM that's the chatbot. So these are a very strong distinction between both sides. Now, I need to revisit a topic before I wrap up my session on the state of AI, because I did speak about the intelligence quotient for AI systems and the scientific underlying as well for it. When we talk about artificial intelligence, we can divide it into three main categories. We can call narrow intelligence, we can call general intelligence, and call super intelligence. All right. As it is right now, we are still in narrow intelligence. I know everybody's talking about AGI, and the likes, right? Everywhere you turn, you see. By the way, if you're wondering what AGI is, it means artificial general intelligence. You and me, we are artificial general intelligence, or we are we are not artificial, pardon me. We are generally intelligent because as you are, right, you can become. If today you decide and say, I want to go and study law, you will be successful at it. It is in your design, right? But the state of AI we are right now is specialized, right? Artificial intelligence are AI that are specialized in a particular domain and task. So I know you're wondering, but you see, oh, ChatGPT can cross domain and talk about a lot of things. It is just a layer, right, of layers. It cannot actually be domain agnostic. It is just a layer of layers model, right? So we're actually still in artificial intelligence. Another one to look at is the ability to understand multimedia information. As human beings, you can hear, you can see, right? You can interact visually and auditorily. For AI, it cannot do that. Those image generation models you see are actually just multiple stack of models, right? It is either the AI can only do image generation or it can only chat. A system that can chat at this present state of AI that we are in, a system that can chat and can also understand visuals from documents or images is a multi-agentic system, right? It is a stack of many specialized LLMs. So we are still not at ASI or AGI yet. We are still at federal intelligence, and we are still very far from getting there, extremely very far, precisely. Quoting Yang LeCun, the godfather of convolutional neural network, in his paper, and also for what he's been saying so far. So you realize that transformer architecture cannot really get us there. But what we are using right now is based off transformer architecture, right? I was having a discussion with Rock that can see. So can anyone see my presentation?
Yeah, was that agentic system stack? That's where we stopped.
Yes, that's where I am. I'm discussing off-road. Yeah, I'm discussing off-road. Right, that's where I am. All right. I was discussing off-road, and I was just about to talk about the multimodality of agentic systems, right? So I was having a discussion with Grok on some weeks, I think it's been a week or maybe a month or two now. I can't recall the time frame precisely. And I was challenging it on its audacity to make claim and fact as it always does. You know, these days when you go on X, people see something, the next they're asking Grok, right? Something that they could even think of, they're asking Grok every single time. Somebody's always asking Grok something. If Grok was a human being, it would have right. So And I was challenging Grok that you're just a transformer architecture. You cannot lay claim to knowing facts. You're just auto-completing your sentences. And he said, yes, I know, I'm just an transformer architecture, but I've been augmented by the X team and the XAI team to part my architecture and relieve me of that accusation. Because I was also pointing it to what Jan LeCun said about the limitations of transformer architecture, not being able to be really intelligent and the likes. So why am I saying all this, right? Because it's fundamental that we know it, right? And it's foundational that we understand it as it is, to be able to build leaders that are not consumers of AI in Africa, but are creators of AI in Africa. That's really important, and that's why knowledge has to be democratized and distilled down to the to even the youngest person in every room, right? Because that's the only way we're able to position Africa in the point where we're not just we're not consumers of technology, but we're also creators of technology at scale, because we already have the data set here. We just need to consolidate them and be able to build something real and ideal. All right, so I'm going to close my talk at this point and open the floor up for questions, if there are any. Thank you.
Yes, please, you can ask your question, Mr. Ma Okoronkwo. Thank you. Okay.
All right. Good evening, Samuel. Good evening, everyone. My question is a bit off, but there's the whole thing around AI agents being held legally accountable, right? Can AI agents actually be held legally accountable? You know, I don't know if this question made any sense to anybody here, but I read it, in passing yesterday, and I said I was going to do a deep research on it, but I've not had time to do it. And I'm like, okay, I mean, we have some earlier on the call. I might just ask him, this very weird question that I read online. So, did that question make any sense?
Your question is not weird. Let me start from there. Your question is actually very ideal, and there's been a question going on for a long time in AI security and governance. So your question is not weird. Your question is actually spot on. As a matter of fact, Microsoft designed their, I think, it's seven-star principle for artificial intelligence that they use for managing their design and development in-house. And one of them is responsible development, accountability, and inclusiveness. So let's focus on accountability and responsible development, right? For any agentic system, and no agentic system is in isolation. It was built by another higher intelligence, right? No intelligence is in isolation. It was built by a higher intelligence, right? So that being said, for agentic systems, let's use an example, an agentic system that classifies fraud, right? So I'm about to pay my airline ticket, right, my flight, and I moved money from my GT account to, say, my Access Bank account, and Access Bank flagged it as fraud because I moved maybe, say, 10 million. That's crazy, right? And then I will meet findings, and then they say it's your agentic system that flagged it. Your agentic system that flagged it, that's Access Bank. That does not concern the user with whether it's your agentic. Who is the agentic system? It is Access Bank. You use autonomous tools. You take responsibility for it. So agentic system cannot take responsibility in and of their own, because they are not in and of their own intelligence. They were designed by an intelligence team, and that team is represented by a corporate liability that needs to take responsibility for it. So yes, when it comes to AI security and governance, right, the builder or the creator of AI is directly responsible for such use. D, don't worry, I'm going to allow you to ask a question. To buttress this further, recall that Sam Altman, some few days, maybe it's up to a week now, too, came to Twitter and made a public announcement, right? I think a video rather of him circulating, maybe it was on a podcast, I can't recall fully, but I recall the context, that when you discuss with ChatGPT, do not, right, do not use or do not put your live data in there, right? Do not put your live data in there. Do not put your personal details there because it is being stored, whether you delete it or not, it is being stored and it will be used if evidence should be provided for a lawsuit. So if someone is suing OpenAI and they ask for evidence of user interaction for those in Lagos, if you go to ChatGPT and cry and said, I have XYZ cache in XYZ location, this is the password, this is the PIN, please save it for me, it will you find the newspaper. You find it on the newspaper, you'll find it directly on blog and on the news, and you begin to wonder, right? You start racing to the bank to secure your account. But that's the reality of it. So yes, your question is not stupid, your question is valid, and yes, creators of AI will take responsibility for AI. Did that answer your question?
Yes, it did. I had like a follow-up question, but I think I'll just let I don't know if there's a guy called D, to ask a question. Maybe I'll come back to it. But it was around moral outsourcing. People
You're
trying to
already
dodge
asking your
accountability.
question. You're already asking your second question. I thought you want to give him for D.
Yeah, apologies. Okay, I'll come back.
Hello, sir. Good evening. Can you hear me?
Yes, it's a bit low, but go ahead.
How about now?
Is this Daniel? I'm going to call you out. You know that, right?
All right,
I know,
I'm
I,
the one.
I know my sons. I know my sons when I hear their voice. All right, go ahead.
Okay. So there are discussions that I've been part of surrounding what technical knowledge do I need to acquire before I can, build my AI agent. I'm a simple business owner, maybe a fashion designer, and I just want to build one simple solution that my customers can use, or maybe just me I can use. And I don't want to spend a lot of money, trying to hire a very senior AI engineer. Or maybe do I have to, or do I not have to, do that? So the question is, how long should I go? How far should I go in getting knowledge? Are there tools or platforms that I can use to, build my own AI agent that I can use? Or do I have to start learning Python or learning Go or learning JavaScript before I can build my own AI agent? So that's the question I have, sir.
Okay, so two or three things. Number one, you want to be a vibe coder. You want to vibe code your way into the promised land. And that is okay. Just that when you vibe code in, you vibe code out. That's one. So two, right? When it comes to discussions around if you can do it without needing any engineer to do it. Yes, you can. I mean, there's N8 and there are a lot of no code or low code platforms that allow you to build agent. There's Comfy UI. They allow you just drag and drop and connect and you have the stuff going on. But you can't serve that to customers. No, you can't. And why can't you serve that to customers? Because when it comes to serving customers, there are a lot of things that only a battle-scarred engineer who has earned his or her honor from production experience in battle scars, or someone who has been specialized in that field can provide you that you do not know. One of them is security. The other one is data protection. The third one is scaling. The fourth one is system and server management. Right. So whether you vibe code your way in, or once you get traction of customers, you need someone with experience to move you further than that. So Yeah, there are low code and no code platforms to achieve that, but to really move forward and build something that really gets users doing what they need to do, you actually need an engineer. You can't skip that part of the journey. It's impossible. Leave all those things they see on Twitter. People are coming to look for likes and impressions. They come on and they just tell lies and they go. It's so painful, right? But when you really come down to where AI agents are really being used, right? You don't find all those things, all those drama and all those things. They don't, you can't buy people your way. I can give an example. I've been doing a lot of projects in the fintech domain recently, and also the traditional banking and commerce domain, implementing AI. And the majority of the problems I've met are data problems, right? And then edge cases that you can't walk your way out of it with vibe coding. You can't. If you give it to an AI, it will fall flat on its face, because these are things that require adaptive reasoning, and adaptive reasoning on the go, not adaptive reasoning on one face. Adaptive reasoning on the go, because when it comes to financial data, everybody forms the structure. It is the bank that now consolidates that structure. Now imagine if many banks form their own different structure, right? So yes, you can actually use no code to get things started, prototype, and but to really build something that really matters and scale, you can't really do that.
Yeah. Thank you very much, sir.
So there are a couple of questions in the chat.
Okay, let me see. Okay, is it just me or okay? That's not the question. How do you evaluate whether an AI agent is good at its tasks? All right, so there are many ways to do that. There's the engineering approach to it. There is also what we call LM as a judge, which do it. I think okay, let's just start with these two, engineering and LM as a judge. Now, what is the LM expected to return? Right? Is it expected to return the data in a particular structure? Right? Maybe your LM is expected to return, maybe your LM is expected to connect to, let's say, the core banking system, like Mono, right? And the extract and make inference of banking statements so users can actually chat with it. Now, it is expected to return accurate information of banking statements. So, which means that when it pulls the banking statement out, reads it, right, the results not directly pass to you. It's passed to another LM that acts as the judge that evaluates, is this incorrect? Now, this extra LLM is looking at the result from the original agent and the original data, right? So it gives you the context and principle of generative adversarial network, where you have a generator and discriminator in a neural network approach, right? Where one sees the image and then tries to replicate it, and the discriminator now checks if it's accurate or not. Right. Now, the other part is the engineering approach, where you can create structures. Pydantic is a very good library that allows you to create structure and then enforce that the result from your agent is correct, right, or it matches it. A third way that you can do that is to force your agent to return citations from where it got the data from. So let's say it goes online to do a research for you, it needs to reference where it got it from. If it cannot reference it, it is wrong. A fourth approach, right? I mean, I can go on and on with all these approaches because some of them are experiences, some of them are ideas in my head. A fourth approach that you can actually use is to force your LLM in your agent to validate itself. There's an approach I used with one of the projects I worked on, was to force the LLM to generate confidence score for every single result it gives you. Right, force to generate confidence score, force to generate source, right, and force to generate freshness of that data. So if it gets the data for you, how fresh is it? Is it coming from memory, or did you just get it fresh from the direct source? How confident is the result that you get? Is it confident that this is originally from the source, or it has padded it by adding its own knowledge by hallucination? So these are ways that you can actually evaluate how your AI agent is good at its task. Okay, exactly. Agent can go to users. Okay, I think that's just a statement. All right. Okay. I think Mission was trying to ask his follow-up question.
All right, thank you very much. So it was around just more outsourcing, right? So there was also this thing that I saw online where people were sort of dodging accountability and, looking for a way to sort of imply that it is the fault of the algorithm, right? So I don't know what you have to say around that, where people are now trying to outsource, their AI ethics to or letting their AI agents essentially make the moral choices. I don't know if I'm phrasing this question very well, but I hope you understand what I'm saying.
Okay, when you say make the moral choices, you mean they don't take responsibility for
Yes, they're trying to dodge responsibility and
I
then put
see.
everything on the AI agent itself.
I see. Well, again, until we have governance laws, right? Last year I was it last year? Should be like 2 years. No, I think it was last year. Yeah. Last year I was with Dr. Bosun Tijani, the Minister for uh, Digital Economy and the Communication, and his assistant, Dr. Uh, what's his name now? I keep forgetting. Dr. Bumi. Yeah. So for the National AI Artificial Intelligence Conference, I don't know if you guys saw it in the news. I called. Yeah, so I was with him, and part of the discussion that we had, right, was uh, how does Nigeria really do things around governance, and part of the strategies that were covered and from that conference was on designing an effective AI strategy for Nigeria. Although it's not yet in full play, it's still being in the works to perfection. But you see, when we have such kind of framework and guidelines that control responsible AI, and accountability. Companies who can build the responsibility, they can show you where their data came from, how they used it, if they're using your data, and the results, and also bringing humanity where possible. And you get to realize that that actually properly brings in accountability. But until then, we'll still have this kind of issues where people can drop the ball. And when things are bad and become fair weather engineers or fair weather institutes, and then throw it on some non-existent civil intelligence system. I know I can be harsh on defining AI, even as an engineer myself, but it's a reality, right? I tend not to follow the general approach of people who are AI influencers. There's a reality in AI that you will not know unless you build with it, right? You still think it is what people have edited and posted on LinkedIn. But that's just the reality of it. I hope I answered your question, Ms. Soma.
Oh, yes, it did. Thoroughly. Thank you very much.
All right. Yes, Olazabad, you can go ahead.
Thank you, sir, for the facilitation. My question is actually around the, should I say, the evolution or the constant um, breakthroughs or development and things that keep changing around the ML AI space. So, from the perspective of the last question that the participant asked, it got me thinking that okay, is the focus of this class for maybe should I say vibe coders or intentional engineers? Because that's a concern for me. Like the question I asked about what level of prerequisite one needs to have coding, Python, and the like. So my question that is um what is actually what is actually happening? Because I know of someone that was discouraged who was so much into analytics and co until the agents started making noise last year and he got discouraged and veered off. So I just want to ask her, what do you advise her as far because I'm interested in this space actually.
Okay, so that's your friend that veered off. He veered off to go and do what precisely? I just like to hear the
In
end of that
fact,
story.
thank you, sir. We're actually in a boot camp, and this guy I respect so much because me, I really didn't know much, but it's the guy who had gone advanced in analytics, building models, and co. So on the WhatsApp group, that was presented around July last year. when Gen started coming out. It was Gen AI we were pursuing. Let's finish this and go do Gen AI. But I never landed there yet. Then Gen he said, guys, go and do business. I'm just quoting exactly what he said on the group, on the WhatsApp group, and he was intentional about it. Though it's not my friend, but during the period of the internship we had for like 3 months, we're interacting, and so I respect him a lot about knowledge, So he was intentional about, guys, go and do business, go and make money. He was just advising money, 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 and I knew this is not just ordinary. So, so I honestly that gave me some concern that with this all this that this guy knows, visualization, statistical analysis, and you know, and he's doing well by model building because when we had a group project, he is like one of the top 3 people that were actually contributing, and we were just by the side. So this one like that could be talking and well.
Okay,
So
so
I'm
let
hearing
me
about
let me
agent AI, agentic AI. I learned is different again.
let me help
That they
you.
are different. Yes,
Let me
thank you, sir.
help you. Let me help you, Lanley. Can I call you Lanley?
Yes, yes, fine, sir. Very fine.
Okay, so I think your problem is you're also afraid that this Agba has dropped the ball and ran. I hope I'm not left in this wilderness. Okay,
Yes, sir.
it's totally understandable. I'll tell you that for free. When I started learning artificial intelligence, no, when I actually decided to specialize in AI engineering precisely, I came on Twitter, I could not find anybody doing that. I can tell you that fact. I could not, in short, the program I did, the internship I did, right? I was practically one of the very few people who actually ended up becoming an AI engineer amongst all of us because it was a very vague context as at the time, very vague. People were either doing data science as data scientists or doing data analytics as data analysts, right? Or doing Power BI design and the likes. Right? So being an AI engineer was such a weirdo using that word. But the truth is that if you are true to what you are, what you want to become, you really don't need to pay attention to the noise because in social media there's a lot of noise. Now I'm just saying this right. You don't have to adapt to it. What I'm about to say next, it is my own personal conviction. But sometimes I deliberately go offline, and my data is not off; it's on, but I'm not there. I'm not there. My data is on because I need that to do my work, connect to my meetings and like. But on WhatsApp, on LinkedIn, on Twitter, I am not there. So if you send me message 10 million times, you'll just be surprised that you have no response because I'm not there. Because sometimes some of these platforms are very rich source of information, but also very rich source of distraction. And I can tell you for free that I am grateful that I did not drop the ball and say, I'm tired, I want to go and do something else. Or I did not look at somebody else's track and use that to create my own track or somebody else's journey and use that to form my own journey. I'm grateful I never did that because today, right? Okay, I wanted to talk about finance, but let me not talk. Let's not discuss that. But today I'm very grateful that I didn't. That let me put it at that point. I'm very grateful that I didn't to encourage you because this is not to encourage you, right? I've worked with Facebook, right? Brought in as a data scientist to work with them. I've worked with companies in the US, right, and in USD, right. Um, I'm saying all this on the call because I don't want you to feel like that guy who has somebody who you respect so much, and because that person has dropped the ball, you also drop the ball. No, is business bad? No, business is great. As a matter of fact, there's something that I read on LinkedIn today. I don't know if it is Sam Altman really said that or somebody else, but he said, when you becomes very senior top senior enough, you end up becoming a salesman. What that means is that every business person is a salesperson, right? So long you're a business person, you are a salesperson, whether you agree or not, you hawk your market. Now, what that also transcribes to is that eventually, with all these things we are doing as engineers, you will end up being a senior and then end up being a business person. Eventually, that's the end of the journey, except you're not ready to retire well. People who know this truth and know peace. Eventually, all this coding, eventually, at one point, you must let it all go so that you can become a senior and position yourself financially better. Very important. So now, how early do you want to do that or set yourself on that pedestal? It's just as how early you are ready to commit yourself and burn the candle and do all the stuff you need to do now to get to that particular level of seniority, which is very, very important. So my encouragement for you is not to look at the journey of somebody else and use that to create your own journey. One, not to look at the noise of social media and use that to scare yourself, because I also had that fear. I told myself many times, I'm not sure AI engineering is going to be a thing. Will I find job in Nigeria with AI engineering? I'm studying that. I'm spending my time studying mathematics like this. But I'm grateful today, right? I'm grateful today that I never dropped that ball. So I don't think I would advise you not to either. Right. So pretty important that you follow that direction. So I hope I answered the question.
Yes, sir, you did. But I wonder, you mentioned mathematics now. So there are a lot of maths to learn in engineering.
Yes, I would like to.
Wow.
Yeah. So you're not going to just integrate Gemini API or connect with API. That's not AI engineering. That's software integration.
Wow.
AI engineering involves mathematics and statistics. You need to understand what's happening with the model. You need to be able to fine tune it. You need to be able to create new ones from scratch. You need to be able to design statistical model of numerical data. That in itself is engineering artificial intelligence.
Okay. Sir, can I add something, sir? Sorry for the
Yes,
time.
please.
It's like I mentioned earlier, my earlier entry into the space was, to a boot camp. So I was doing an internship. That was a newbie. I had no prior knowledge of Python, and that was a real deal breaker for me. So I entered again into the same internship the next quarter, by which time I had some fear, let me say 5-10% of self-taught Python. And at that time, I joined another track because I had in
Mhm,
mind that I want to be I want to just know what's happening in every track. I did
mhm,
storytelling, did data science. Then the last one I did data engineering, where by that time I had some, let me say 40% by my own ranking. At least I was a little fluent, if I could use that word, in Python programming language. So, and it was at that time that I started hearing about engineering. All I had before was ML, which I don't do in engineering. I mean, for the first time, precisely speaking, that was about July last year to August, there about. I about NLP then, yeah, engineering. Wow, this could be interesting. So I now veered or go again into it. Let me say a bit more mature now, in my own definition of maturity. So, but then to wrap it up and cut the story short, when I was through with a little few weeks of NLP um, training I attended, I became more interested in NLP language modeling, the likes. Maybe should I say I want to push back the modeling I didn't know, so to say, maybe due to Python and the likes. But then I find it more interesting, to be frank. So I'm not following the person, but I'm following my own track. So I just need to make reference to it. But to now make a reference to what you did last time, I was thinking maybe it's really people that will go into research and maybe advanced degrees that will need to bother more about mathematics, But if someone wants to be a developer, building apps, doing this, maybe you may not really need to. That's my thought too. That's why I ask since you mentioned mathematics. Thanks, sir.
Yeah, a software engineer is different from an AI engineer. They're not the same thing. Software engineer that builds apps, servers, you don't really need that heavy much more than AI. You need data science and algorithm heavily, right? Um, but that you don't need that too heavy to survive. So let's not just scare body away, right? Um, the one I'm referring to is AI engineering, not software engineering. Do you understand,
Okay.
Larry?
Yes, I do. I do.
All right, cool.
Thank you so much.
All right. Yeah, so I think I'm just going to stop here to save the time and hand the call back to Michael.
Thank you so much, sir. Can we say thank you message to Mr. Sam, Dr. Sam, like I usually like call him. Thank you so much, sir, for this session. Thank you. It's been an eye opener. But yeah, I was literally writing all through. So there are a couple of things I actually need to go back to, and I don't, that's why I said, like I do not take the fact that we even had him this long on the call. It's something I do not take lightly. It's something I don't take lightly. Thank you so much, sir. We are grateful. We are grateful. So here at Mindfulness Academy. Mindfulness Academy is an edtech organization that recently launched, and then we're offering a couple of programs across cybersecurity, um, AI machine learning, and data science and analysis. So we recently launched a new program called Generative AI and Chatbot Builder Program. So it's basically generative AI essentials, right? So people that are new into AI, right, and want to get know a bit more about generative AI, right? So learn about generative AI, prompt engineering, and then AI agents, building AI agents. So there's the 4 month plan, right? That runs longer, where you actually get into the mathematical aspect, like you do the deep dive. But then this is actually for people that okay, you've heard about generative AI, and you want to know okay what it does and how you can apply it to your everyday life. Or if you're probably making use of it at the moment, you want to see how you can maximize it. So this program is for you. It's a 4 weeks program, right? It's actually 2 weeks. There are two tracks. So there's the 2 weeks and then there's the 4 weeks. So like I said, it's like essentials, right? But then it's the bottom line is to get you started. And so for those that registered, you'd get when getting the recording for today's session, you'll actually get a link for those who be willing to register. If you're also an AI dev, right? But then you have younger ones, you have friends that actually want to get started, you have teachers, you have anybody that actually wants to make use of Gen AI, right? And understand okay what it does. So this is the program for them. So chatbot, like Dr. Sam had explained to us, are part of the things that actually um putting importance today, right? We see them in our WhatsApp, we see them in our fintech applications, and so on and so forth. So if you actually want to learn how these things work and how to build one that you could make use of, so this is a program for you. So there's a 2 weeks program and then there's a 4 weeks program. There's also a consolidated fee for the early bird, and you could, when getting the email, right, for today's recording, you're also going to get the more information about it. So bottom line, we want to say a very big thank you for making our time. First off, thank you, Dr. Sam, for the privilege to come here. We do not take it lightly. Thank you, everyone that took our time. I believe that today's session, night session, has been worth it, and we made the most out of it. So thank you, everybody, and keep on doing the best. My name still remains Mike Madu, and till when next we see. Thank you, everybody, and have a lovely evening. Good night. Bye, everyone.